Hello students, this is AJAY Pandery here. I am teaching you mathematics for class 12. Your mathematics book which has two parts, part 1 and part 2. This part 1 book have around 6 chapters in it. If I go to the index, I can see there are 6 chapters, and the first chapter to start with is relations and function. Here is one scientist given in the first page. You should be knowing that he is JPGL Dirichlet. He is a German mathematician. In early 1800s, we have learned about him that he has given theory of Fourier series. Then he has his contribution in number theory also, and at the same time he is best known mathematician for his modern definition to function. Okay, now today I have to start the topic, that is relation. Relation is a literature word. We use this word every day in our day-to-day life. It is just a link between any two person. Say is father of, is brother of, is less than, is greater than. These are the relations. It is a relation between any two numbers. Say is less than objects. So right now, let us take a very simple example to understand the word or the term relation. Think of your family first. Suppose I term your family as set A. Okay. Now your family have, say I am taking the minimum 3 members: father, the mother, and wife for you. Okay. Now this is a set. In mathematics we say that a set is a collection of well-defined distinct objects. So if I think of Cartesian product with the same set A, that is again we have to write father, mother and you. Then the Cartesian product of the two sets A cross A, the cardinal number was 3, 3 3s are 9. So we'll have father, 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 mother and father, you. Similarly, mother, father, mother, mother and mother, you. And perhaps you, father, you, mother and you with you. Okay, there are 1 2 3 4 5 6 7 8 9 okay elements in A cross A. Now we can understand that each possibility which is been paired is a special relation. What kind of special relation? Father and father. Father is same as father. So I can think of, when I say father, father, I have a relation implies father is related with father. Okay, with a relation, say R1 is the relation, and R1 is same as father is related with mother, father is related with mother, with a relation F R2 M, and the relation is R2. We can say, what is the relation between father and mother? Is F is a husband of M, so is husband of. In this way, in a family, say suppose if I think of father and you. Okay, so father and you, what is the relation? You are the son of, or the father is the father of you, isn't it? So there are so many relations within a set. So relation, perhaps it is well known that relation R is a subset of A cross A. It is a proper subset of A cross A. Relation is a subset of A cross A. Fine. Now in this topic relation, we have to know one very important type, that is equivalence relation. What is equivalence relation? I will tell you equivalence relation. If you want to know, then you should know three things. Equivalence relation, EQUY, VALENC, equivalence relation. Equivalence relation, okay. This equivalence relation consists of three things. One is reflexive relation, symmetric relation, and the third one is transitive. Now, before I go to this reflexive, symmetric, and transitive relations, when I come to types of relations, we should be knowing that there are reflexive, symmetric, and transitive. Apart from this, there are two more relations. One is called empty, and the second one is universal. And we have a very simple example to make you understand what is an empty relation. Um, Empty relation, if I take a set A and say set A has 1, 2, 3, the three elements, and now I want to take a different set, let's say set B, which is 4 and 6 perhaps. Then, as per class 11's concept, A cross B, that is Cartesian product of A and B, it is 1, 4, 1, 6, then 2, 4, 2, 6, then 3, 4, and 3, 6. Then I have to define R. Say I want to take R is a relation, say x comma y, such that x is less than y. If I say x is less than y, and this x comma y belongs to A cross B, you can see x is less than y, x is less than y. In all the cases, x is less than y. All the elements of A cross B belong to this particular relation R. So this is an example of universal relation. The other one is, if I say R is a relation x comma y such that x is greater than y, then obviously there are no elements. X is less than y, less than, in each case it is less. So there are no elements which qualify for x greater than y. Such relation is called empty relation. So when we define this universal relation and empty relation, we can write in a way: a relation R in a set A is called empty if no element of A is related to any element of B. If no element of A is related to any element of B, then such relation is called empty relation. And obviously in that empty relation there is only phi is null, the set is null. Now a relation R in a set A is called universal. A cross B is universal if every element of A is related to every element of B, or each element of B. So universal relation consists of all A cross B. Empty relation will have none of the elements, so we say it as phi. Fine. So empty, universal, these are two relations. Apart from this, there is equivalence relation, which consists of reflexive, symmetric, and transitive. I need to make you understand what is reflexive relation. I have a very simple method with which I think of reflexive. Reflexive means my reflection. So my reflection means if I am element A from some set capital A, then my reflection is the A itself. So reflexive relation means A comma A belongs to R. Always remember this way. Very simple. That means the relation is applicable on itself. For example, if I think a relation of a kind is friend of, I am a friend of myself, so obviously is friend of qualifies as reflexive relation. So is friend of reflexive relation. There can be one more relation. The relation is equal to, is equal to, is equal to is also reflexive relation. Is parallel to, you may not be knowing that a line is always parallel to itself. So this line L1 is parallel to itself, so L1 is parallel to L1, so it is also reflexive relation. So whenever you think of a relation called reflexive, do remember the words is friend of, is equal to, is parallel to, all they qualify for reflexive relation. Reflexive relation is a relation which is with himself only. Then comes symmetric relation. Symmetric relation, a relation R in a set A is said to be symmetric if say A is related to B with some relation R, with some relation R, say A is related to B, implies we should have B also related to A, okay, under the same relation. If A is related to B and we get B also related to A, just like that commutative property, then we say that R is symmetric. Now in this symmetric relation you can understand that the examples like line 1 and line 2 I am taking, okay. So we can easily say line 1 is parallel to line 2, implies what? Line 2 is also parallel to line 1. So we can say is parallel to is symmetric relation. Then comes is parallel to a symmetric relation. Is less than, if you want to check is less than, so 2 is less than 4. I'm checking R as is less than. 2 is less than 4, but 4 is not less than 2. So R is not symmetric. So students, you can understand that reflexive relation is a relation within itself. Symmetric relation, you have to have two fingers, you have to see like this. If X is related with Y, then Y is also related with X. So this means it is symmetric relation. Let me tell you what is transitive relation. Transitive relation. Say if A is related to B, we are taking A, B and C from some set A, and say we are checking this relation under A cross A. So R is a subset of A cross A. Say A is related to B and B is also related to C for some relation. Then if it is proved that A is also related to C under same relation, then R is transitive. So for transitive relation, you can understand that if A is related to B and B is related to C, then obviously A has to be related to C, then only we say that the relation is transitive relation. In a particular relation, if it is established that it is reflexive, it is symmetric as well as transitive, then we say that the relation is an equivalence relation. Now I can give you one example of equivalence relation. For example, in your NCRT book, there is one question. The question is, say, NCRT book page number. If you do not get the book right now, you can always go to Diksha app and get the book downloaded from there. Now they have given check whether R in set Z. You know what is Z? Z is integers defined as R equals to x comma y such that x minus y is integer. Is this an equivalence relation? Symmetric, reflexive and transitive? I need to check. Obviously we can start with like answer if you want to write. We know that for reflexive I have to check x related to x such that x minus x will give me 0, and 0 belongs to integers, so R is reflexive. Again I repeat, when I find reflexive I find relation of x with x only, and the relation is x minus y has to be integer. I subtracted x with x, I got 0 and it is integer. Yes, it is reflexive. If I have to check for symmetric, x related to y gives me x minus y belonging to z as integer. Okay, then y related to x I need to check implies y minus x. Obviously I'll get a negative number, and negative number belongs to integer only, maybe positive or negative. These two will vary with one negative sign, one positive sign, and both are admissible in integers. So that's why if x is related to y, that means the subtraction will give me integer. Y is also related to x because the subtraction will give me integer only. Transitivity. For transitive, I need to have two inputs. X related to y implies x minus y belongs to integers. Y related to z implies y minus z also belongs to integers. Then I need to check x related to z. X related to z. This can be written as x minus y plus y minus z. X minus y plus y minus z is x related to z, which is x minus z. Perhaps I needed to write x minus z. No. So integer minus plus integer is always integer. So R is transitive. So you can see that the relation which is given x minus y is integer, it holds equivalence relation because it is symmetric, reflexive and transitive. Moreover students, like after this first class, you can always download the worksheet which is available in the net. The link will be given. Okay, this is your worksheet. If you can see it right now, this is your first worksheet which you have to complete and then be ready for the second class, which is tomorrow. Thank you.